Hi, in this video we're going to be doing some practice problems about enthalpy. So first, in some situations, heat can be added to a system if the temperature of that system does not change. Propose an example of this situation and explain why the temperature does not change. Alright, we talked about this a few videos ago. And this is an example of a system where increasing heat doesn't increase the temperature, is melting. Heat energy is used to break intermolecular forces in the solid, allowing the particles to freely move past each other. The heat is being used to break the intermolecular forces. That is why the temperature is not increasing. Number 2, it says the following reaction occurs as solid ammonium nitrate is added to a beaker containing 450 milliliters of distilled water. So this is our system. Everything else will be the surroundings. So is water part of this? It is not. So water is the surrounding. Is the glass beaker part of this? It is not. So it's also surrounding. Is the NH4NO3, which is this, part of the system? It is, because it is what's being reacted. NH4NO3 is the substance undergoing thermochemical change. Everything else will be the surroundings. Next, if you wrap your hand around the outside of the beaker, you will feel, will your hand feel warm or cold? Alright, so for this one, the answer is going to be cold, because this is an endothermic reaction. So the system absorbs the heat from its surroundings. Because heat flow goes from hot to cold, the heat in our hand will get absorbed into the beaker. Losing heat in our hand causes us to feel cold. Basically, the heat in your hand is being flown into a beaker, and that's why you feel cold. No, flowing into the system, which is inside the beaker. Now, during the period of time that your hand is wrapped around the beaker, is your hand part of the system or part of the surroundings? Again, anything that is not part of this is a surrounding. So, again, it's going to be surroundings. Number 3, suppose 391 kJ of heat is released when carbon monoxide gas reacts with nitrogen monoxide gas. According to how many grams of carbon monoxide are consumed during this reaction? So first, we have our negative 391 kJ of heat being released. Because we have 391 kJ being released, that's what's the negative. So negative 391 kJ released into its surroundings. Now, next, for every one reaction, alright. For every one reaction, how much heat is released? It's 746. So it'd be negative 746.6 kJ. Now after that, every one reaction, how many moles of carbon monoxide are there? 2 moles of carbon monoxide. Yep, and finally, for every 1 mole of carbon monoxide, it asks for how many grams. How many grams is carbon plus oxygen? It is 28 grams. 28 grams of CO. So first, we use from the we use what we're given, convert it into one reaction, and then for every one reaction, there are 2 moles, and then converting from moles to grams to get our final grams after it releases negative 391 kJ of heat. So let's see, negative 391 divided by times 2 times 28 divided by negative 746.6 divided by 1 is equal to 29.3 grams, and this will be 29.3 grams of CO. Now next one, the thermochemical equation for the combustion of methane is below. How much heat released when 28.4 grams of methane gas is burned? Alright, so this is just like the previous one except flipped. So first, let's start with what we're given, 28.4 grams. 28.4 grams of methane, which is CH4. Next, for every 1 mole of methane, how many grams is that? C plus 4 H's will be 16.05 grams. Next, for every 1 mole of CH4, there is for every one reaction, there is 1 mole of CH4. Now that we have reactions, let's keep going. In every one reaction, there is negative 802.3. Negative 802.3 kilojoules. And that is it. We're ending up with kilojoules because we want how much heat in kilojoules. So 28.4 times 1 times 1 times negative 802.3 divided by 16.05. We get negative 1419. 142, about negative 1420 kJ of heat. And this will be also known as 1420 kJ released. Either one of these answers will be correct, but I prefer to go with the negative one. All right. Next, ammonia is produced from a reaction between hydrogen gas and nitrogen gas. All right. Does the forward reaction absorb or release heat? Since the forward reaction is negative 92, it is going to be release. It's exothermic. Release because deltaH is negative. How much heat is absorbed when 45.8 grams of hydrogen gas react with excess nitrogen gas according to the reaction above? And it's going to be the same thing as we did previously. 48.5 grams. First we convert it to grams. No, first we convert grams into moles. 1 mole has 2.016. 2.016 grams. That's the H2. And then every reaction there's 3 moles. One reaction will be 3 moles of H2. And then for every one reaction, we have negative 92.2 kJ of heat. So 45.8 times 1 times 1 times negative 92.2 divided by 2.016 divided by 3, which will get negative 698 kJ of heat. And finally, number 6, BaOH2 times AH2O, okay, all that. Is a reaction endothermic or exothermic? Let's see. It is positive. Positive, delta H, means it's endothermic. Endothermic. How much heat is absorbed or released when 16.8 grams of NH4Cl react with excess hydrate? So this time it's 16.8 grams of NH4Cl. NH4Cl, yes, alright. So same way, 1 mole of NH4Cl. Let me do the math real quick. Add all these together. And we will get 53.5 grams of NH4Cl. Okay, now that we have that, for every one reaction, how much NH4Cl we have? We have 2 NH4Cl, 2 moles of NH4Cl. And after we convert into one reaction, we can now convert into heat, which is 80.3 kilojoules. 80.3 kilojoules. And our final answer will be now be in kilojoules. 16.8 times 1 times 1 times 80.3 divided by 53.5 divided by 2. We'll get an answer of 12.6 kilojoules. And this time it's going to be positive. And again, grams and grams cancel, moles and moles cancel, reactions and reactions cancel, which gives you kJ. So you basically have to work away. You just have to keep working your stoichiometry until you get your unit that you wanted. And on part C, if this reaction could be reversed to produce 16.8 grams of NH4Cl, how much heat will be absorbed or released? Alright, this time we're reversing reaction. Now when we reverse a reaction, you need to remember that the heat, the kJ, the delta H, everything remains the same. So here in the previous one, we found that in the forward reaction, it takes 12.6 kilojoules. Now if we were to reverse it, it's going to be the exact same number, 12.6 kilojoules, except this time it will be released. Because over here, in number B, it's being absorbed. And now when we reverse reaction, it will be released. Since the reaction is simply reversed, the energy amount will stay the same due to the law of conservation of energy. And that's it for this video. Thank you for watching.